So let's consider again the statistics that we just looked at in problem 11. Would you expect the 98% confidence interval to be wider or narrower than you calculated before? Okay, so let's take a look at this. If we were to draw a distribution, and I'm going to draw, let's just say that these two distributions, these t distributions are exactly the same. Now I do a 98% confidence interval. So let's say I go from there to there. Okay? So I'm going to shade that in. I shaded in 98% of my t distribution. Okay? Now this one I'm going to shade in 90% of my t distribution. So I'm going to go from there to there. Okay? 90%. Well, which one is wider? Well, this one is. Okay, the top one is because I went farther out from the mean. I shaded in more of the t distribution. So the higher the percentage, the wider the interval is going to be. Okay? The other way to think about this is if the mean is here and I was to calculate this t value, I'm going to call this t sub 90. And this t value will be the same, and it'll be positive, and this is t sub 98. If I was to go and get those t values, which we did in the last problem, if you remember, okay, then what happens? This t value would be larger. Okay, this t value would be farther from the mean. It would be a larger number. So when I go and I calculate my interval, x bar would be the same. T would be larger for the 98% confidence interval, S would be the same, and N would be the same. So the only variable that changes is T. And in a 98% confidence interval, it's going to be larger, so hence my variable, my interval is also going to be larger. Okay? So now what are the advantages and the disadvantages? Okay? Well, the advantage is the 98% confidence interval. I'll just put B. It has a greater chance of containing the true mean body temperature of adults. Okay, it's a wider interval, so it's more likely that you capture. You're more confident. If you're 98% confident as opposed to 90% confident, you're more confident. So what's the advantage? You're more confident because you more likely captured. What are we trying to capture when we're looking at a t interval? We're trying to capture mu. Okay, what is that mean body temperature? Okay, but what did we give up? Well, we gave up precision. However, the interval is wider, and therefore less precise. Okay? So whenever you increase your confidence, you lose precision. Okay? So that's the answer to B. So C, if we can conduct further research, this time using a sample of 500 adults, how would you expect the 98% confidence interval to change? Okay, well, I can explain this two ways. Okay? We have a t distribution, right? A t distribution with a smaller sample is flatter and wider. A t distribution with a larger sample is like a normal model. It's higher and narrower. Okay, so if I shaded in 98% of this bottom one, where n is 500, as opposed to shading in 98% of this guy right here, okay, this is where n is 50, let's say. Well, this is wider than this. Okay, that's explanation number one. Explanation number two is this. Your confidence interval is x bar plus or minus t degrees of freedom, s over the square root of n. Well, what happened when you changed 50 to 500? Well, n increased. Well, if n increases, it's on the bottom of this fraction here. So when you increase the bottom of a fraction, what do? You make the number smaller. Okay? So if I make this smaller, then I'm adding or subtracting a smaller number, hence I'm going to get a narrower interval. Okay? That's answer number 2. Answer number 3 is this t. Okay? Remember that we did 98% confidence interval. So let's just say here, I'm going to make degrees of freedom for this example 50, even though it would be 49. I'm going to put in the calculator as 50, and this one I'm going to make 500. Okay, and you'll see why in a second. Okay, if I go and I say, okay, I want a 98% confidence interval. So we drew that up and we said, okay, inverse t, and we did 0.99, comma 50. We get a t value of 2.4. Okay, but if we do 500, we get a t value of 2.33. So again, that's going to make, if I have a larger n size, it's going to make the confidence interval narrower. Okay, so that's the third explanation of why the interval would be narrower. Okay, so the t distribution would get narrower. Your sample size, when it increases, it makes the interval narrower, and when you find your t value, the larger your sample size, the more it's going to approach a normal model, especially when it gets over 200. That's going to also make it narrower. Okay. And then last question, how large a sample would you need to estimate the mean body temperature to within 0.1 degrees? Okay, well, that 0.1 degrees is the margin of error. And the margin of error is this piece of our formula. Okay? Now, we got a problem. The problem is we can't do inverse t unless we know n. And if we don't know n, we can't do degrees of freedom. So we can't use a t. So what can we use to approximate a t? We use a z distribution. That's the best we can do. We cannot do a t distribution if we don't know the number of degrees of freedom. If we're looking for sample size, then we can't do degrees of freedom. We have no idea what it is. So, again, you got a 98% confidence interval. I always like to draw it out. It helps me. Shade in the middle 98%. Okay, so that's 98%. So what does that mean? That means that there's 1% here and there's 1% there because I got 2% left over. That means that this starts at the 1 percentile and ends at the 99th. So now I'm not going to do inverse t, I'm going to do inverse norm to approximate. So I'm going to say, okay, inverse norm, 99th percentile, 2.326. So I'm going to do 0.1 equals 2.326. Now, what was our, you got to go back to problem 11 to get your standard deviation, but it's 0.6824. Okay? Divided by the square root of n. So that's what your equation is going to wind up being. Okay? So, I'll go through how to do this. I divide 0.1 divided by 2.326. I get 0.043. That's 0.043 equals 0.6824 times the square root of n. Multiply both sides by the square root of n. That gets rid of that. So I got 0.043 square roots of n equals 0.6824. Divide by 0.043. And that's 15.87. And then what do I got to do? I got to square both sides. So I divided 0.043, 0.043, and then I'm just going to square that answer to get rid of that square root. So I'm going to square that 250. So to be on the safe side, I'm going to say I need a sample size of about 252. So n is approximately 252. Okay. That's what we got there.